Hi guys. So I can start because this went off. So. All right. So I'm going to start. Yeah. So today I'd like to do a small presentation on dependency injection in JavaScript with InversifyJS. So who's here has heard of dependency injection or have played around with it? How about dependency injection in JavaScript? Or InversifyJS? No?
Just heard.
Cool.
Not you.
Alright, so, but before that, I'm going to introduce myself. My name is Dzul. I am a developer at Geta. I've been there for over 7 years now, I think. Geta, for those who don't know, we are an IT solution firm based in Oslo, with branch offices around Europe and the US. So we build all kinds of applications, we provide all kinds of solutions, mostly based on .NET and the API Server CMS platform. Yeah, I've been in development for, I don't know, over 10 years at least now. Occasionally I write at Nasir.com. I have a GitHub repo. I'm not very active on social media, but you'll be able to contact me or follow me on Twitter. Okay, so what is dependency injection? So the literal meaning is to inject a dependency. Yeah? And in software development, a dependency is simply another class that your class needs to operate. For example, if you have a model which fetches data from a database, that database is a dependency for your model. So now that we understand what a dependency is, what is dependency injection, right? So dependency injection, to put it in simple terms, is really a programming technique where you push the dependency from the outside rather than instantiating it from inside the class. Like for example, you have an application class here. Traditionally, what you would do, or at least in the past, what you would have done is you would create a new instance of your dependency using a new operator. But instead of doing that, dependency injection tells you to pass in the dependency as either a constructor parameter or using a setter. And that's pretty much it. That's dependency injection in a nutshell. But why is dependency injection so important? And the reason why dependency injection is important in development, in software development especially, is because of the dependency inversion principle of the solid design principle that states that code should depend upon abstractions and not upon concretion. So what this essentially means is that your code should have their implementations abstracted from each other, or decoupled from each other, and they should instead rely on an interface to interact. Yeah? And by using interfaces, we can then substitute different implementations of the dependency, as long as they satisfy the required interface without needing too much of a code change. So, how does dependency injection benefit you? Okay. Dependency injection encourages us to decouple our code from its lower level implementations, and this results in cleaner, code that's cleaner, that's easy to modify, and that's easy to reuse. It also makes it easy to test our code, because instead of having to work with hard-coded implementations, we can just pass in a mock dependency during, say, unit tests. And it also results in faster development. But this is subjective because it depends on the size of your team, depends on how your workflow is. But let's say, for instance, you have a small team, and all you have to do is decide on the interfaces, and after that, individual members of the team could continue working without having to worry about how those interfaces are implemented. So essentially, the consumer of the dependencies shouldn't have to worry about the implementation details, but instead they should only have to worry about that they can rely on the fact that that implementation will give and will return a predictable result. So let's look at a simple example. Let's say we have this application class, and we, as you can see, we are instantiating a dependency from within the class, right? In this case, it's a logger. We then implement this throughout our entire code base, right? You don't have to be like a genius to figure out that this is actually a bad idea. And then, sometime in the future, you decide that, okay, we have a new requirement that we want to send our logs to a cloud-based logging service like Logly or Raygun, if anyone's using any of those. Now, in order for us to do this, we would have to replace the instantiation code throughout our entire code base, right? So a couple of problems with this. Firstly, this is no fun, right? Imagine having to go through your entire code base looking for instances of this. Secondly, it's error prone, because even if you use something like replace all, it doesn't necessarily mean that everything's going to be fine and dandy, because you might have an instance where well, the usage of that class, well, I don't know, maybe you're abusing that class for whatever reason. You know? And thirdly, but this is really my opinion, that this is really stupid. You know? Because you can train a monkey to do this. What if instead of doing that, we pass in, we use dependency injection and we pass in an interface, right? This way, we can pass in anything we want. We can pass in this logger, or we can pass in the HTTP logger, and we wouldn't have to make any changes to our code, or like nothing big. So I would say that this is a much better way compared to like the traditional method, right? And yeah, I've also mentioned previously that another field where dependency injection is beneficial is unit testing. So dependency injection makes it easier for you to substitute your code's dependencies. So let's say we want to test this code, right? But we have a hard dependency right there. And since we've instantiated our dependency inside our class, we can't switch it out with anything else. Let's say, for example, a unit testing specific logger class, for example, right? And then you have to ask the question, should you really be posting logs during unit tests? Obviously, no. So using dependency injection, we could pass in something like a null logger, or a stub class or something, doesn't matter. It doesn't do anything during the unit test, since the objective of the test is to test the class and not the logger, right? Okay, so now that we've established what is like dependency injection, and why it's important, right? And then we decide that, okay, this is cool, let's implement dependency injection throughout our entire code base. But then you have a problem. Because as your application becomes more and more complex, you'll start introducing more and more classes with more and more or deeper dependency trees. Now, not only do we need to know what dependencies our classes need, we also need to know how to construct those dependencies. And this is where dependency injection containers come in. So, fundamentally, dependency injection containers are nothing more than a map of dependencies for your class, with the logic to create those dependencies if they haven't yet been created. So instead of creating the classes and dependencies yourself using, say, the new operator, you let the the container take care of it. Let's say in this example, for example, we want, we ask the dependency container, hey, give me an instance of class 1. And the dependency container, the dependency injection container knows what kind of dependencies the class 1 requires. It looks for them, and then if it hasn't already been instantiated, it creates an instance of that, stores it in the registry or a cache, and then returns, before that it constructs the object along with the dependencies and returns it back to you. So that's basically what it does. So we've heard of dependency injection containers in backend languages like .NET or like C#, .NET Framework, Java, right? But rarely do we hear about this topic mentioned in JavaScript. So this is where Inversify comes in, because InversifyJS is really a dependency injection container for JavaScript. Yeah. It brings the dependency injection concept, or like the technology itself that we backend developers have backend full stack developers have taken for granted for years to the world of JavaScript. Yeah. Like for example, in .NET we have structure map. I'm not sure what you guys have in Java, like Spring or something like that. And so we didn't have anything like this in the past. Okay, so it is strongly typed because it's powered by TypeScript. Any TypeScript guys here? Yes. Okay, and because regardless of how you feel about TypeScript, it really is great. It does give JavaScript developers the ability to use some high-performing tools, and also it provides some like really great features like error or type checking during development or compile time. So that minimizes the chances of you making a mistake during development. You know, like you want to pass in a number, but instead you get a string, for example. So InversifyJS will compile to JavaScript, meaning that it will run in browsers, Node.js, and any JavaScript engine that supports ES5, ECMAScript 5, or Neo. It is framework agnostic, so you can use it in your Angular applications, your React or Vue applications, or the last one's Backbone. Yeah. And it's been designed in such a way that that makes it possible to integrate with popular frameworks such as this. And it has a very friendly API that makes it really easy to just jump in and start using. So let's just go through some basics. This is described on the website, but I'm just gonna go through it. We're gonna go through like some code demos anyway. So, but just so you guys get a basic idea of how it works and how to implement it in your application. So firstly, you install Inversify using your favorite package manager, like NPM or Yarn or the NPM or whatever else that people have come up in the last 30 minutes. Okay, then firstly, we have to create an interface. So unlike strongly typed languages like C#, Java, and so on, JavaScript doesn't have interfaces. So, and this is pretty much why we have to create a constant here that will be used to identify this specific interface. This will be used later on when we hook everything up. So I'm just specifying, I'm just telling you what it is and why we need it now. Next, we create our classes and define our dependencies. So as you probably have noticed, we have this guy here. And this is, we have an inject decorated right there, and as you can see, we have that constant that we mentioned in the previous slide. So what this does is that it essentially tells Inversify what you want to inject into this class as the parameter for, as the value for this parameter. Next, we implement the interface, and this is like up to us, like how we want to implement it, what we want the code to do. As long as you satisfy the interface requirements or the interface declaration in this case, everything should be fine. You shouldn't run into any build compilation errors because TypeScript is really strict about that. And again, we have another decorator here. Injectable decorator. This also comes from Inversify. It basically tells Inversify that, hey, this is a class that you can inject into your container. And then we have to set up the container. This is the only place where there will be any coupling, because throughout the rest of your code, you shouldn't be referencing any other classes. You should only be referencing interfaces. Okay, and finally, we need to resolve our first dependency, and which essentially kicks off the entire dependency resolution process. And preferably this should really be done at the application composition root, or like, for example, the application entry point. Okay? And all these subsequent dependency resolution will be taken care of by the container. Okay, that's pretty much like what dependency injection containers and Inversify is in a nutshell. So what I'm going to do now is showcase some a demo app. So is it okay if I turn it down a bit? Can you guys still see it? Is it still okay? I wasn't sure how big text would look on the screen. So, okay. So as we mentioned, firstly we declare our interfaces, and I skipped the part where we declare this a constant as an identifier for the interface, because you can. In TypeScript, you can do something like this. You can there's a helper library called ts_nameOf. Essentially, what it does is that it takes the interface, interface, and it spits out a string with the name of the interface. So it's pretty useful if you don't want to do the whole, I want to create create the constant that you then use throughout your entire code base. So I really recommend this. So I have this interface here, and then I have my implementation. So this class, all it does is that it fetches 10 random images from the cat API, if anyone's heard of that one. And you can see here that I'm injecting a logger here. And all I'm doing is that I'm passing in an instance of the interface. And I'm expecting something will be injected into my as the value of this parameter, which I can then use in my code. So there are two ways to do this. One is by passing in the dependency as the constructor parameter, and the second one is declaring it as the value of it using the setter, basically. So you can do something like this. Sorry, my hand fingers are really cold. So that, then you can get rid of this, and everything will still work. It's essentially the same thing. You can go about it like one way or the other. It doesn't matter. As long as you use this decorator, it will Inversify will set the implementation that you have provided to that property. So next thing, I have a small class here that depends on all these things. Like, okay, I want an image repository implementation. I also need an implementation of iLogger. And this service basically all it does is that it fetches images from those repositories and creates like image divs. Finally, we have our configuration. So this is basically where the coupling happens. What we're doing here is that we're telling Inversify that, hey, whenever someone asks for an instance of an iLogger, yeah, pass in the console logger. And whenever someone asks for this guy, just pass in this guy. Right? And as you can see here, we have to pass it in like this. You know, if you guys worked with structure map, you would see something like this instead, right? This is usually how you would do this in structure map. Like find or map, or create map, this and that. And you can also do something like this. So let's say you have a class. Class is something that JavaScript has. So you can essentially bind the class to itself. And what this does is that anywhere, it allows you to inject that specific class in other classes that require it. So you don't have to do this whole, I'm going to create an iImage service, but this is the only implementation of it. You know, but I'm going to have to do this anyway because I want to follow the whole convention thing. But you don't have to, and you can just like do this instead. So once we've done that, we have this one entry point where we fetch the first dependency, which incidentally is this application class here. And this kicks off the entire dependency injection, like dependency resolution process. So, and we only need to do this once, really, like for an application. If you have multiple entry points, you'll have to do it for every single entry point, obviously. And all this thing does is that it logs a couple of things, and then it fetches the image block, and it appends the image block to this HTML element. Okay, so let's see what else. So, as you can see, I'm getting my cat images, and also you can see that I'm getting all my logs like logged out. And okay, so let's say we want to add a new implementation of the logger, for instance, and I have something. I'm just going to pull the code from this guy. So I'm going to save that. Then I'm going to add implement. Just going to add a load the logger thanks. And man, I should have done this before. Implement iLogger, then okay, and implement iLogger. Okay, so as you can see in TypeScript, if you don't implement the interface, it's going to like complain about it. So you get that red squiggly lines. Next, I need to pull this guy, and I have to do this because TypeScript is pretty strict. And the next thing is is I need to implement these guys. So next, I'm just going to pull this guy in, right? And same with this guy. I'm just going to pull that one again. Okay. And finally, all we have to do is update this guy. Update the configuration file. And we can pull, I want to use the lovely logger. Oh, and I almost forgot. We have to do this, inject the role. Yeah. Otherwise, Inversify will complain about this. So once we do that and we go back to our application, you can see that we no longer get logs in our console, and instead, if we do this, you can see that okay, I'm like posting a bunch of logs to logly, and I didn't have to make any changes to my to the rest of my code base. All I had to do was add a new implementation, update the configuration, and rerun and recompile. That's it. You can do all kind of, yeah, you can. Okay, so that's one thing, yeah. So and the next thing is like I mentioned earlier about unit testing. So the really cool thing about Inversify is that it simplifies your unit test processes, right? Because you don't have to say implement. Well, you no longer have concrete dependencies. So in my case, I had the what do you call it? The logger, which now is posting log data to my logly account. But I don't want to do that during my unit test. So let's kill this guy. Instead, what I want to do is I want to use a time mock here to create a stub with a stub implementation of my interface, which I am assigning or I am binding to the iLogger interface. So what you have to do, well, what I normally do, and this is the recommended approach, is that you can fetch an instance of the container from your which is basically your configuration. You create a snapshot of it. You unbind whatever it is that you want to replace, and then you create a new binding. So in my case, I'm binding the iLogger to a parser value, which is just a mocked object. And after each, you should restore the container for subsequent unit tests, because like the future unit tests might not want this implementation of the iLogger. Maybe you actually want to test the iLogger. So anything that you mock, you should restore it back to its original state after each test. So, and this is essentially what I'm doing here. Like I'm creating a mocked version of the image repository, because all I want to do is I want to test this image service, and I want to see if it's actually calling the get images method. So so when I run this test, I'm using Karma and Puppeteer, if you can consider that. So yeah, and basically I'm running all these tests in a headless Chrome instance. So usually, in the past I had these like Chrome instances popping up, and then or I used Phantom.js, but it seems like they've killed it off or something, and now then I switched to Chrome headless. Okay, so the unit test was a success, and I don't even see, I'm not doing any logging. I don't see any log in my code, because everything's, well, the log method has been, the log class has been mocked, and all I'm doing now is that I'm just testing the image service class. that's it. Let's see. Okay. I mean, from my end, I think that's pretty much what this is all about. Let me just resume this. Okay. So that's pretty much it regarding like dependency injection containers, InversifyJS, and some code. Because the reason why I wanted to do this is mainly because I don't normally hear about dependency injection in JavaScript. I always hear it in .NET, C#, and I don't work with Java, so I can't speak for Java. And I'm of the opinion that if something can be written in JavaScript, it most likely will be. So, and you see this all around, like dependency injection is bring into JavaScript world. I just say that. And yeah, and I also think because it's a great technology, and we should all be using it. So, question, yeah, typo. Any questions regarding this topic? Or was that like, you know, so deep?
Yeah.
Yeah.
Like, would you use dependency injection in JavaScript in any application?
Yes. We
Like
currently
even calculator application?
if you want to, why not?
Would you use?
Well, it depends on what you want to do, really. Because the reason why we have dependency injection in the first place is because like application starts becoming really complex, and we don't want to have to keep track of every class and their dependencies and how to construct the dependencies and all that stuff. I just want to build my app and, you know, let infrastructure take care of what it's supposed to do. You know? So yeah, if the calculator app is complex enough, then sure, why not, right?
Question like that. In languages like Java and C# you mentioned,
Yes.
there's a good practice of not really bringing dependency containers somewhere deeper rather than just composition root.
Right.
So how do you approach that in JavaScript?
The same approach, essentially. At least that's what I've been doing in my applications. We are actually using Inversify in our projects, and we only have just a single per app, basically, because we have multiple applications in our entire solution. So the configuration itself is per application basis, at least at this point.
I mean, using the container, because using the container in like the deepest, as highest level as possible. Because if you bring the container deeper, you depend on things that are not exactly explicit.
Right. Yeah. So it's I guess I would say that it's pretty much the same approach. Just have the configuration as close to the composition root as possible. Yeah. And this is something that they've described in their documentation. Yes.
What are the reasons it's not very popular in JavaScript, and does it work well with React?
I don't know exactly why it's not popular, but I assume it's because JavaScript applications have always been like not session-based, but you know, if you need to restart the application, you just like reload the page and everything resets. And when you want to kill the application, you just like close the tab, right? I assume.
No compilation, right?
Yeah, there's no compilation. There's nothing, and you can. And every time you navigate away from the page, you're basically restarting the application with different components, maybe. So, but now we see that single page applications are really popular today, especially with the progressive web app. So, and this is no longer the case. You don't navigate away from the page anymore. And this this basically puts all the complexity of the application into like one box rather than multiple like smaller boxes. Like you go homepage, just that's it. You know, go to another page, that's it. But we no longer see this. And so I suspect that's why dependency injection wasn't popular in the past. But this is just my opinion. I don't know. You know.
What do you think? For example, I, the man who write the logger class, you, the man who will use this logger class, who is responsible to write an interface in between?
Well, that's something I guess you would determine amongst yourselves, I suppose.
So I write the logger class, I write the interface to use, and then someone else who want to write different implementation of logger and use.
Well, I think the way that you can look at it is like if you were building a plugin for an application, naturally you would set up the interface for the plugin, and the consumer would look at the interface and say, oh, okay, this method will return this, you know. Or if you need something more specific, I assume in most cases you do, you probably would discuss between the two team members, for instance, you know, discuss like, okay, you know what, I need this kind of data so that I can show it on the UI, make it happen, right? So what kind of methods should I be calling, and what kind of return values should I be expecting? And the other guy, the guy who implements the interface, would just then, okay, I understand your requirements, I'll just implement this. You know, how it's done? Well, I don't care. You know.
Are there stuff like default implementation, so you don't need to rewrite for all the cases?
Yeah, that was something.
Default logger.
Yeah, I know. That was something that I also thought about myself, because in structure map we can just scan the entire entire project, for instance, and then it can automatically create the mapping for you. But unfortunately, I haven't found anything regarding that, so I assume I guess it doesn't work that way. Although Microsoft has also created their own implementation of dependency injection, even though they're actually using Inversify in their projects. So they created there's a GitHub repo called I think it was TS Syringe, I think, something like that. TS Syringe, yeah, and they have something like an auto mapper kind of implementation. Yeah, so I guess maybe that's the way to go if you want everything to be automatically mapped. But I mean, I like having I like having control.
Yeah. But if it becomes too large,
yes.
Too
I understand.
boilerplate.
Yeah, I understand. Yeah. Because our C# or .NET implementation on the backend side is huge. And obviously, you don't want to go through the configuration. Like just okay, I have a new interface. I need to add it to the configuration, for instance. And yeah, but maybe when our application gets that complex, at least on the JavaScript side, we'll probably have to revisit this question. But at the moment, it's okay. For our needs, yeah. It's good enough for our needs. So, any other questions? Because, I mean, it's okay if you don't want it. I mean, if you're shy or something, then we can just, talk afterwards. And also, or you can contact me on Twitter. I have a Facebook account, but I don't remember the last time I opened it. Yeah. Twitter then. Sorry.
Okay, thank you.